Dear students, very good afternoon. I am Dr. D. Prasanta Bharati. So yesterday we have seen an important formula using the diagram u, and u is the function of x as well as y, and both x and y are the functions of t. Both x and y are the functions of t. So if so, u can be differentiated partially with respect to x, and it can be partially differentiated with respect to y. Here x can be differentiated with respect to t by using ordinary differential equation concept. So here also dy by dt. Since x is a function of one variable, we can use ordinary differentiation. But here u is a function of both x and y, we have to use the partial derivative formula. Now the first formula is when u is the function of x comma y and x equal to a function of t, and y is another function of t, then we have du by dt equal to dou u divided by dou x into dx divided by dt plus dou u divided by dou y into dy by dt. Dou u by dou x into dx by dt plus dou u by dou y into dy by dt. So this is our first formula. So under this we can use total derivative of implicit functions. We can find differentiation of implicit functions. So what is implicit function? Implicit function means a function is depending on some other function, and that some other function is also depending on other functions. Here u is a function depending on x and y, a variable. So a function depending on some variable, and those variables are not actually a variables. Those variables are also the functions of some other variables. So according to u is dependent and x and y are independent. But for x and y, they are dependent and t is independent. So ultimately t alone is an independent variable. So these kind of functions are called implicit functions. So this is our first formula. And now you understood what is mean by implicit function. Now if I suppose instead of, if here x is a function of t and y is also a function of t, if instead of t I want to use x, okay, instead of t, if I want to use x, means the above formula will become the following case. That is, first u is the function of x and y, and both x and y are not the functions of t. Y is again Okay, y is again the function. Y is again a function of x. That is, this u can be written as dou u by dou x, and this u can be written as dou u by dou y, and this case can be written as, since y is only the function of x, y is depending only on x, we can write dy by dx, dy by dx. So we get our second formula as, so du by dx, du by dx equal to, so how to reach u, how to reach this x from u, so du by dx equal to dou u by dou x. Okay, here we are having two path to reach t, so we write dou u by dou x into dx by dt, but here there is only one part to reach x, so only we will have dou u divided by dou x, dou u divided by dou x plus, and to reach this x there is another way having two different parts, that is dou u by dy into dy by dx. So we can write dou u divided by dou y into dy divided by dx. So this is second important formula using this diagram. So first formula depends on this diagram, second formula is depending on this diagram. So these two formulas are used for implicit functions. Also we are having some other formulas. So differentiation of implicit functions not always be a function. Here use a function of x and y. So it cannot be always a function. Sometimes it can be a constant, or it can be a relation. It can be a implicit relation between x and y. It can be implicit relation between x and y. On such cases, we can write, if I suppose that instead of u equal to x comma y, if I am having this function f of x comma y equal to a constant, this this function is the implicit relation. Okay, this function is the implicit relation. Implicit relation means we will not be able to split up the given function separately as the function of x or separately as the function of y, and in those cases both x and y are also functions of some other variables. Okay, so relation between x and y. So here f is having the constant, f is equal to constant. So how the function of x and y will be the constant means, then we can define this. So we can define, it is not necessary to go for this formula, we can simply define this formula. So here instead of u I am taking directly f, that is d f by dx equal to, so instead of u, because u and f are equal now, but here I am not taking u, I am taking directly f. So df by dx equal to dou f by dou x plus dou f by dou y into dy by dx. Okay, so since f is constant, what will be the derivative of constant? The derivative of constant will be 0. So 0 equal to dou f by dou x plus plus dou f by dou y into dy by dx. Now it implies I want to find this dy by dx. So this dou f by dou x will come on this side, and the dou f by dou y in product will be come to the denominator. So the term dou f by dou x will become negative. So dy by dx. So dy by dx equal to minus dou f by dou x minus dou f by dou x divided by dou f by dou y, dou f by dou y. So here we always know when a denominator becomes 0, then the whole term will become infinity. So it is very important to avoid that situation. So here the important condition is dou f by dou y should not be equal to 0. Dou f by dou y should not be equal to 0. So this is our third formula. This is our third formula. Okay, so the first formula is composite. The first formula is we know that du by dt. The second formula is du by dx. The third formula is differentiation of implicit function. The third formula is differentiation of implicit function. Okay, now the fourth formula. Now, so these two were the formulas for total derivatives. The formula for total derivatives, but the third formula is the formula for implicit function. So c itself can be written as the function of some other variables, but here it is treated as constant. So that's why we, instead of taking u, we have taken it as c. So on differentiating the c, it will become 0. So this df by dx will become 0, and so we get this relation. Okay, so this is possible for the first differential coefficient of an implicit function. What this dy by dx is the first differential coefficient of an implicit function. Now we are going to study the fourth important formula. Now we are going to study the fourth important formula. The fourth important formula is again du by dt. Now instead of u depending on two variables, here we are taking u depending on three variables. That is u equal to the function of x, y and z. U equal function of x, y, z, whereas this x is a function of t, y is a function of t, and z is a function of t. That is, for example, x equal to phi of t, y equal to psi of t, and z equal to delta of t. Okay, z equal delta of t. If u is a function of x, y, z, and all x, y, z are the functions of t, means then the diagram will be so here we are having u. Okay, here we are having u. This u is the function of three variables x, y and z, and everything is the function of t. So this u can be differentiated partially since u is depending on three variables, dou y by dou x, and this is dou u by dou y, and this is dou u by dou z, dou u by dou z, and and here we can write and here we can write dx by dt. Since x is a function of one variable, we can write dx by dt. This can be written as this dy by dt, and this can be written as dz by dt, dz by dt. Now while reaching this t from u, how to write that? So we can write du by dt, du by dt equal to okay, du by dt equal to dou u by dou x into dx by dt, dou u by dou x into dx by dt plus dou u by dou y into dy by dt. So dou u by dou x into dx by dt, dou u by dou y into dy by dt plus dou u by dou z into dz by dt plus dou u by dou z into dz by dt, dou u by dou z into dz by dt. So this is our first formula. This is our second formula, and this is our third formula. Now this is our fourth formula. Okay, this is our fourth formula. This depends on this diagram. Now, so this formula is called composite function of one variable. So this is also composite function of one variable, but here that is both x and y depends on one variable t. Here also both all x, y, z depends on one variable. Composite functions means x and y are functions of t. So that is functions depending on one variable. Here x, y and z are three different functions depending on a single variable t. Okay, so according to you, x, y, z are variables. According to x, t is a variable. So when x, y, z are treated as variables, u is a function. When t is treated as a variable, x, y, z are the functions. Okay. So now we are going to take two variables, composite functions of two variables. So for that, for composite functions of two variables, we are going to take two variable case. So if suppose z equal to f of x comma y, if suppose z equal to f of x comma y, where x is a function of two variables, that is phi of u comma v. Here x is function of one variable, here y is function of one variable, that is composite function of one variable. Here it is composite function of two variables, that is x is a function of two variable as well as y is also the function of two variables, that is psi of u comma v, then z can be treated as the function of u and v. Then z can be treated as the function of, it can be treated as the function of u and v. Okay, so now for this we can make a diagram. So here first we are having z. So Z is depending on X and Y. X and Y. And both X and Y depends on U and V. Both X and Y depends on U and V. So I am writing here U and I am writing here V. So X is depending on U, also X depends on V. Y depending on U as well as Y depending on V. So here z is a function of two variables, x is a function of two variables, and y is a function of two variables. In such cases, ordinary differentiation will not be implemented. So here it is dou z by dou x. Here it is dou z by dou y. Here it is dou x by dou u. Here it is dou y by dou u. Here it is dou x by dou v. Here it is dou y by dou v. So now how to reach? Now we have to think how to reach this u from z as well as how to reach this v from z. So here we will have two formulas. Here we will have two formulas. One formula is dou z by. So here order differentiation is not coming. So we have dou z by dou u. Dou z by dou u equal to dou z by dou x into dou x by dou u plus dou z by dou y into dou y by dou u. So dou z by dou x into dou x by dou u plus dou z by dou y into dou y by dou u. Second is dou z by dou v. So dou z by dou v is here. So how to reach this v? So we are having dou x by dou z by dou x. Here we are having dou z by dou x into dou x by dou v. So dou z by dou x into dou x by dou v plus dou z by dou y into dou y by dou v. So these are the 5 important formulas. These are the 5 important formulas that we used to find the total derivatives, that we want to find the differentiation of implicit functions. So in all these scenarios, the formulas that we need to use is only these 5 formulas. Apart from this, we will use the basic differentiation formulas. Other than those basic differentiation formulas, the formulas meant to solve the differentiation of implicit functions and to find the total derivatives, we have to understand, we have to memorize, we have to clearly have in our mind the concept of these 5 formulas. So these 5 formulas are very important. I hope this video is very useful for you. Let us meet in tomorrow's class. Thank you all for watching this video.